So we're going to continue talking about exponents and do some multiplying with like bases. So let's just recall what exponent is. If I have a to the b power, then a is my base and b is my exponent. So we're going to run through a series of problems. And we are actually going to find out what the answers actually are. But we're going to try to do it with thinking about it rather than just plugging it into the calculator. So if I say 5 to the third, let's talk about how we can get that. What kind of thinking would you do in order to find what 5 to the third is?
Well, negative.
5 to the third, what does that actually mean? Yeah. 5 times 5 times 5. So doing this in our head rather than just plugging that into the calculator, how would we think about that? What'd you say? Yeah, because this equals 25. So 25 times 5. Anytime you have 25, think about quarters. So that's like, you have quarters, you have 5 quarters. How much is that? $1.25. So we'll put 125. Okay, the next one is going to be 5 squared times 5. So what does that mean?
5 times 5 times 5.
Okay, so 5 times 5, which is that 5 squared, times 5. It's the same thing, yeah. So that really means it's 5 to the third. So I can rewrite it as 5 to the third, which we already know that, right? 125. Okay, let's do 5 squared times 5 squared. How would we think about 5 squared times 5 squared? What'd you say? Oh, 5 to the fourth? Okay. Why do you say that? You just added those exponents to 2 plus 2. Okay. And so then how do we find 5 to the fourth?
5 times 5 times.
No, we're not going to put it in the calculator. We're going to think about it. Okay. So 5 times 5 times 5 times 5. 25 times 25. That's one of those perfect squares. 25 squared. Do y'all remember your perfect squares?
No.
This is usually the last one that we learn before we just use the calculator after that. 25 squared. 625. Okay, could we think about this in terms of the 5 to the third power? So we could just use that 125? Because this is 5 to the third, right? The 5 times 5 times 5. What was that? 125. And then times another 5. Which I think about that as 5 times 100, which is 500. And then 5 times 25, 125. Add 500 and 125 is 625. That's just a way to do mental math. I need y'all to stop playing. Okay, so then we could actually think about this 5 to the fourth as 5 to the third times another 5. Okay, we're gonna switch gears now and let's look at a different base. Let's do 2 to the third times 3 to the second. How do we find that? What do we got to do?
2 times 3 times 3.
Okay.
3 times 3.
Times 3 times 3. Okay. So can I do this? 2 times 2 is 4. 4 times 2 is 8. What's 3 times 3? So 8 times 9? What? What'd you say?
72.
72. That's a weird 9. There we go. Okay, so since we've been talking about just adding our exponents, let's think about this again. 2 to the third times 3 squared. I'm going to ask a question. Is that equal to 6 to the fifth? Could I multiply my bases and add my exponents?
Yeah.
I can do that?
No.
No? Okay, how do we know? How can we prove it on our paper that these aren't equal?
6 to the 5th is not 72.
Okay, so 6 to the fifth really means that. How do we know that's not 72?
So 6.
Mm-hmm. So I can go ahead and do 6 times 6 is 36. Right?
Another 6 times 6 is 32.
No, 36 times 36 times 6.
Oh, yeah, 36 times 36 times 6.
60.
Do you think that's going to be more than 72?
Yeah.
Yeah. So they are not equal. But let's find out what this 2 to the third times 3 squared is with a base of 6. Let's see if we can get a base of 6 somehow. So I'm going to rewrite this like I did earlier. 2 times 2 times 2 times 3 times 3. Now I want to get a base of 6. So I'm kind of like manipulating the numbers, changing them up. But I still want to be equivalent to that 72. So how could I find some 6s in here?
3 times 3. Wait, no, 3.
Yeah. 3 times 2. Is there another 6?
No, 3 times 2.
Another 3 times 2. So I could rearrange this. Can you rearrange multiplication? Yeah, because 2 times 3 is the same thing as 3 times 2.
3 times 6 times 6.
So 2 times 3, 2 times 3 times 2, right? Okay, yeah. 6 times 6 times 2. Which is 6 squared times 2. So we were able to get a base of 6, but I still have this 2 out here because it didn't have a match to make another 6. But we know that this does not equal 6 to the fifth. So there is a way to get a base of 6, but it's not going to be by adding those exponents. So our rule here is you must have like bases. If you don't have like bases, you can't add your exponents. All right, so let's look at something similar to like our bell ringer. 2 to the A times 2 to the B. That is an A. Looks funny. So what does this 2 to the A actually mean?
1.
Do we know what A is? No. So how do we do 2 to the A? What does 2 to the A mean? What do exponents mean?
Multiply by itself.
Yeah. So 2 to the a means 2 times 2 times 2. Continue to multiply by times 2, but how many times? We don't know. A times. And then 2 to the b, how could we expand that out? Same way, yeah. 2 times 2 times 2. And these dots means I'm going to continue to multiply times 2 in between those other 2's. But I just don't know how many times because it's b times. So then the 2 to the a times 2 to the b, it's like our bell ringer. We would just add our a and our b, and that would find out our total number of times that 2 is being multiplied. So this is 2 to the a plus b. So you can have an operation up there in that exponent. You don't just have to have a number or a variable. You can put an operation up there like addition. All right, so then x to the a times x to the b. So I have a x as my base and a and b as my exponents. So all variables do, all the letters do is replace a number. So this would be x to the a plus b. So this is kind of our rule. So this is pretty important. Okay, I just have 2 more problems for you. All right, we're going to do 2 to the a squared b times a to the 4th. So we have been just simplifying when you just have 2 numbers. Well, now we have a number,
Yeah, I'll do that.
and then an a and an a and a b. Do what?
That's it.
Have them all together. So how could I simplify this? Because mathematicians are always looking for ways to write things simpler. It kind of starts out a little confusing, but then we need to simplify it. Can I switch around the order? So I can write this as 2a squared, a to the 4th, b. All I did was rearrange it. Multiplication, you can do that. So then what do I need to do now?
Add the 4 and the 2.
Yeah, add the 4 and the 2. So I still have that 2 there, but now how many a's will I have? 6. A to the 6, then b. And that's simplified. Not too bad, right? Okay, let's do one more. 3 a to the 4b times 5 a squared b cubed. So on that last one, I can rearrange.
This one.
So this one I need to rearrange too. So what do I need to put right next to each other? The A's right next to each other
The B.
and the B's. What about these constants out here? What do I need to do with those? Add them, but what operation is happening here? Multiply. So I'm going to rearrange them so I have my constants. The constants beside each other, so 3 times 5. Then a to the 4, a squared, b, and b cubed.
Why would you be?
Hmm?
Oh, never mind.
Oh, so you just rearranged them.
Yep, I just rearranged them. So now I can simplify it because what happens with this 3 and 5? Yeah, multiply together. So I get 15. Yep, and then I can combine my A's. A4 and A2 make A6. B and B3. If there's nothing there, what does that mean that is? It's a 1. So that becomes 1 plus 3, which is 4. All right, so how do you feel about multiplying with like bases? Hard, easy,
It's just
just right?